Assalamualaikum. Today we are going to solve October-November 2024 S1 paper whose code is 9709/52. Our first question: at a college, the students choose exactly one of tennis, hockey or netball to play. The table shows the numbers of students in year 1 and year 2 at the college playing each of these sports. So one student is chosen at random from 120 students. Event section and are defined as follows. X, the student is in year 1. N, the student plays netball. In part A, find probability X slash N. So actually in this part, the slash represents the conditional probability. If the wording would be used, so you have to note that there would be, definitely there would be the word given that should be written. So from there you can recognize that this question belongs to conditional probability. So I can say that probability X intersection N divided by probability of N. So it's a kind of formula. So X intersection N. So this is X is a student in year 1 and N are student play netball. So here is the value X intersection N, if you can also understand this. So 12 over total is 40. 12 plus 28 makes 40. Now you can simplify this. 12 over, no, this will become 3 by 10. Find probability N slash X. So we can write its formula. Probability N intersection X over probability of X. So N intersection X is the same as X intersection N. That is 12. And probability of X. X are student in 1 year. So 16 plus 22 plus 12. This gives us the total 50. So you write 12 over 50. And if after simplification you get 6 over 25. Determine whether or not X and N are independent events. So for this independency, probability X intersection N should be equals probability of X into probability of N. Okay, probability of X intersection N. So this is N of X intersection N over N of S, means total students. So that is x intersection n was 12. 12 over total students are 120. That is given in the question. After simplification you get 1 over 10. Okay, probability of x. Probability of x that is 16 plus 22 plus 12 means 50 out of total 120 students. Okay, this is 5 over 12 and probability of n, this is 12 plus 28, this 12 plus 28 was n, means 40 over total students 120. So this is 1 by 3. So now we can put all these values in the formula. Probability x intersection n was 1 over 10 equals probability of x was 5 over 12 times probability of n was 1 over 3. So these are not the same, so we can say that x and n are not independent events. One of the students who play netball takes 8 shots at goal. On each shot, the probability that she will succeed is 0.15, independently of all other shots. Find the probability that she succeeds on fewer than 3 of the shots. So since n is fixed, means number of trial, n it's fixed, and that is 8 shots. So this is a binomial distribution. So for binomial distribution, the formula is NCR P power R Q power n minus R. P is success, Q is failure, and failure can be calculated by subtracting 0.15 from 1, which is 0.85, and success is given, that is 0.15. Okay. Fewer than 3 of these shots, it means probability x is less than 3. So probability x is equal to 0 plus probability x is equal to 1 plus probability x is equal to 2. Now for 0 probability, 8C0, 0.15 power 0, wait, times 0.85 power 8 plus x is equal to 1, so 8C1 0.15 power 1 times 0.85 power 7 plus 8c2 0.15 power 2 times 0.85 power 6. From the calculator you get values 0.272 plus 0.384 plus 0.237. Finally you get 0.8947. So approximately 0.895 up to 3SF. Okay, question number 2. Find the number of different arrangement of the letters in the word algebraic. So there are totally 9 words and you count the repeated words, and that is A, and it repeats 2 times, so you divide it by 2 factorial. So 9 factorial over 2 factorial. So this is 181,440. Find the number of different arrangement of the 9 letters in the word algebraic in which there are no more than 2 letters between the 2 A's. Okay, sorry. 2A, B. No more. There are no more than 2 letters. I can say that there could be 1 letter, there could be no letter between. Okay, so if I make arrangement for that, so look, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I write A together, so they become one word. And the rest of the 1, 2, 3, 4, 5, 6, 7. So we can say these are 7 and this one 8. So I can say 8 factorial in 8 factorial ways, because these 2 A's can move on these places. So that's why we count them as 1, and there are 7 numbers. So they exchange with each other. So totally they make 8 factorial ways. So 8 factorial answer you can take from 8 factorial. Okay, before taking its answer, let's do another way. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I write A here and A here, so there are look, there are 1, 2, 3, 4, 5, 6, 7, and there are exactly 7 places for A's to, like this A can be moved here, and this A can move here. There should be a gap between them. So 1, 2, 3. 1 is where they are right now. 2, 3. Now 4, 5, 6, and 7. So I can say that 7 into 7 factorial ways. There is one more. There should be 2 gaps between them, because in the question he said find the number of different arrangement of the 9 letters in the word algebraic in which there are no more than 2 letters between the 2 A's. So 1, 2, 3, 4, 5, 6, 7, 8, 9. If I write first A here, then 2 gaps, and then no more than 2 letters. So this is one way. This is second way. Third, fourth, fifth, sixth. So 1, 2, 3, 4, 5, 6, 7. They make 7 factorial, and the denominator, the lines in the denominator, they make 6 ways. So I can say that 7 factorial times 6. These could be the arrangement. So now we can calculate their values. So 8 factorial plus 7 times 7 factorial plus 7 factorials times 6. So the answer is 105840. Alright, question number 3. A fair coin and an ordinary fair 6-sided dice are thrown at the same time. The random variable x is defined as follows. If the coin shows a tail, x is twice the score on the dice. If the coin shows a head, x is the score on the dice if the score is even, and x is 0 otherwise. Draw probability distribution table for that. Okay, we can make a diagram for this. Here is our x, 1, 2, 3, 4, 5, 6. Number of dice. Okay, there is head and tail. So if you can understand its statement, if the coin shows a tail, x is twice the score on the dice. So this, if it shows tail, twice the score. So twice of 1 is 2. Twice of 2 is 4. Twice of 3 is 6. Twice of 4 is 8. Twice of 5 is 10. Twice of 6 is 12. Next, if the coin shows head, x is the score on the dice. If the score is even. Okay, score on the dice if the score is even. So 2 is even, so 2 comes here. 4 is even, 4 comes here. If it shows a head. 6 is even, 6 would be here. Okay, and x is 0 otherwise. So if the dice does not show even number, then you have to pick 0. So 0 here, 0 here, 0 here. That's how you fill this. Now from here we can draw the probability distribution table. X, probability of X equals X. The probability of 0 is how much? 0 occurs 1, 2, 3 times. So 3 out of total are 12. So 3 out of 12. Probability of 2. So 2 occurs 1, 2, 3, 3 times. 1, 2, 3. Oh, no. This is not 2 here. This is 4. So 2 occurs 2 times. So 2 out of 12. 4 occurs 2 times. So 2 out of 12. 6 occurs 2 times. So 2 out of 12. 8 occurs just once. So 1 out of 12. 10 occurs just once. So 1 out of 12. 12 occurs just once. 1 out of 12. So this is your probability distribution table. Okay, variance of x. So where the formula for variance of x is e of x square minus e of x whole square. So e of x square is you just multiply the x, square the x and then multiply it with its probability. So you get square of 0 times 3 over its probability 3 over 12. Then plus square of 2 times 2 out of 12 its probability plus square of 4 times multiply its probability 2 out of 12 plus square of 6 times its probability 2 out of 12 times square of 8 multiply by its probability 1 out of 12 plus square of 10 multiply its probability 1 out of 12 plus square of 12 multiply its probability 1 out of 12 minus e of x square. So that is 0 times 3 over 12 plus 2 times 2 over 12 plus 4 times 2 over 10 plus 6 times 2 over 12 plus 8 times 1 out of 12 plus 10 times 1 out of 12 plus 12 times 1 out of 12 and you square it. finally you get 35 minus 9 over 2 whole square. So your answer is 14.75. There is nothing difficult in this question. Actually, you have to place according to the formula the values in it. Question number 4. The heights in meter of white pine trees are normally distributed with mean 19.8 and standard deviation 2.4. In a certain forest, there are 450 white pine trees. How many these trees would you expect to have height less than 18.2 meters? So this is a normal distribution question. So x is normally distributed. Mu comma sigma square. And to standardize, we use the formula z equals x minus mu over x minus mu over sigma. So mean equals mu equals given 19.8. Sigma square equals variance, and it is given, actually standard deviation is given, so I have to square the standard deviation to make it variance. So now x is binomially distributed 19.8 comma square of 2.4. This is sigma square. So probability x is less than 18.2. So it means probability z is less than 18.2 minus 19.8 over 2.4. So probability z is less than minus 0.667. So this is actually on the left side of the, you see the diagram here, this is a 0, so somewhere here, this is minus 0.667. So you have to flip it on the right side, make it positive, so you have to do one minus, first find out probability of 0. Negative is not there, so when you flip it on the right side, it becomes positive 0.667. So you can see this in the table, and from the table you can find out its probability and then subtract that probability from 1. So let's find out 0.667 from the table. So when we flip this minus 0.667 on the right side, so we have to subtract 1 minus probability of z is less than 0.667. So let's find it out from the table. 0.6, 6, So 0.66 gives us 0.7454, and we have to write 0.7454, and 7 we will see it from here. So we have to add 23 in it. So we get this value 0.7477. That's how we see it from the table. So let's write it there. So 1 minus 0.7477, the value of probability z is less than 0.667. So we subtract this from 1, we get 0.2523. So number of trees 450 times 0.2523. So this come out as 113.53. So the number of trees would be definitely 114. It's a round-off value, or you can write 113 trees, the complete 113 trees. Okay, the heights in meter of red pine trees are normally distributed with mean 23.4 and standard deviation sigma. It is known that 26% of red pine trees have height greater than 25.5 meters. Find the value of sigma. So let's say it's H. H is normally distributed, and our mu is 23.4 and sigma square. So probability H is greater than 25.5, and that is equal to 26%, which is 0.26. So 26% means 26 over 100, and 26 over 100 is 0.26. So 0.26 is somewhere here in the diagram. If you see, this is 0.26 is here, and the rest of the area, I'm coloring it with blue. This is 1 minus 0.26, because the whole probability is 1, so subtract 0.26 from 1, you get 0.74. So we will look for phi of 0.74. So you will not see this figure in the main body of the table. Find closest to this value. So let's go. Okay. So 0.74, actually we cannot see this in the main table, so we have to find closest value to this. So 0.73 0.7389. So this is the closest value to 0.74. You can write zeros from your side. So you need more 11 numbers to make it 0.74. How? Look, 0.7 3, 8, 9. If I add 11 in it, sorry, this is 9. So 8, 9, 10, 4. So this becomes 0.74. So I need 11 more to add in it. So now in add table, this side, look, I'm circling it ADD. You don't see 11 down there, but you can see the closest to 11, which is 10. So pick this one. It is in front of this value. So pick 10. And now add 3, which is above 10. This number you have to add in it in 0.64. So you add this in. Now your actually number is going to be picked as 0.6 and 4 from here and 3 from here. So you get 0.643. 0.643. Now you can write probability Z is greater than 25.5 minus 23.4 over sigma. This is equal to 0.26, and now it becomes probability Z is greater than 2.1 over sigma equals to 0.26, and the story of 0.26 I have just mentioned you. So this becomes 25.5 minus 23.4 over sigma is equal to 0.643, which we looked from the table. So from here sigma equals 3.27. Question number 5. In a class of 21 students, there are 10 violinists, 6 guitarists, and 5 pianists. A group of 7 is to be chosen from these 21 students. The group will consist of 4 violinists and 2 guitarists and 1 pianist. In part A, in how many ways can the group of 7 be chosen? So this is a simple thing. You have to do 10C4, 10 violinists, and pick 4 out of them. 6C2 and 5C1. And use your calculator to find out the answer. So 15750 is your answer. On another occasion, group of 5 will be chosen from 21 students. The group must contain at least 2 violinists, at least 1 guitarist, and at most 1 pianist. So at least 2 violinists, at least means not less than. For example, when it says at least 2 violinists, it means 2 or more than 2. So at the most 1 pianist, at the most means not more than. For example, when it says at the most 3 people, it means not more than 3 people. So we have to pick group of 5 out of 21. So let me write like this: violinist, they are 10. Guitarists, they are 6. Pianists, they are 5. So I have to pick 2 violinists, 2 guitarists, and 1 pianist. So 10C2, 6C2, and 5C1. This gives me 3375. Then there is another option. If I pick 2 violinists, I can pick 3 guitarists and no pianists, because I have to maintain 5, group of 5. So 10C2 times 6C3, and this gives me 900. Another option to make a group of 5 is pick 3 violinists, 2 guitarists, and no pianists. So 10C3, 6C2, and 5C0 actually you can write, or no need to write. So 1800 from here. So another option is 4 violinists, 1 guitarist, and no pianist. Keep 5, number of 5. So 10C4, 6C1, and no need to write 5C0. This gives us 1260. 3 violinist, 1 guitarist, 1 pianist. So 10C3, 6C1, and 5C1. This gives me 3600. So total is 10935. So let me check 10C4 times 6C1. Okay. Question number 6. Teams of 15 runners took part in a charity run last Saturday. The time taken in minutes to complete the course by the runners from the Falcons and runners from the Kites are shown in the table. Draw a back-to-back stem and leaf diagram to represent this information with the Falcons on the left-hand side. Okay. Falcons on left side and Kites on the right side. So from Falcons, 38 means 3 should come here and 8 should goes there. So the stem is 3 and the leaf is 8, and I will write key, which is very important. Five / any number you can pick from the table. If I pick 52 and 50, so means for left side 50 and for right side 52. So this is my key, which is very important to write. Okay, now pick the numbers from the table. So 38 means 3 in the middle, 8 on the left side, and 39 means 3 is already in the middle, so 9 is on the left side. Now no more 3 in falcon. So for kites it is 32, so 2 right on the right side. Then comes 4, and for falcon 44, 46, 48. So 42 means 2 here, 44 means 4 here, 46 means 6 here, 48 means 8 here. And for the kites 40, 40, 45, 47, 48. So 40, 40, 45, 47, 48. Then comes 5, and for falcons it's 50, 51, 52, 56, 58, 59. So 50, 51, 52, 56, 58, and 59. And for kites it's 52, 54, 58, 59, 59. Then comes 60s, so 6 here. For falcon 64, 69, and for kite 60, 61, 63, 65. Then comes 7, and only 76 we have. You have to now calculate the values in the next part. Like he says, find the median and interquartile range of the times for falcon. So there are 15 in number total. Teams of 15 runners. So total are 15. This is odd, so divided by 2. So you get 7.5. Approximate it to the next number, you get 8. Look for the 8th value under falcon. So let me do it with different color. 8th value. So 1, 2, 3, 4, 5, 6, 7. This is your 8th value. And the reading is 51. So it means your median is 51. So your median is 51. Now interquartile range. For interquartile range, find upper quartile, and we write upper quartile as upper quartile, and this is 3/4 of the total value, and total is over 15 runners. So if you simplify this, you get 11.25, round it off to 12. So look for the 12th value. Let's see where the 12th value comes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12th. So 12th value comes on 9. So it means you have to read it 59. So your upper quartile is 59. Now look for lower quartile. Lower quartile is 1/4 of the total frequency, and your frequency is 15, and you get 3.75, which is rounded off to 4. Now look for the fourth value in the table. So fourth value, 1, 2, 3, fourth value comes on 4. So the reading is 44. So your lower quartile equals 44 minutes. Now interquartile range is upper quartile minus lower quartile. So upper quartile was 59, lower quartile was 44. So your final answer is 15 minutes. Let x and y denote the times in minutes of a runner from falcons and a runner from the kites respectively. It is given that sum of x equals 792, sum of x square is this, and sum of y is 783, sum of y square is this. Find the mean and the standard deviation of the times taken by all 30 runners from the two teams. Alright, so because he asked us to find mean and standard deviation from the two teams, so mean is sum of x plus sum of y over n1 plus n2, and this gives us, the values are given, 792 plus 783 over 15 plus 15, and this gives us 1575. This is the mean. For standard deviation, I can use a formula, sum of x square plus sum of y square over n1 plus n2 minus sum of x plus sum of y over n1 plus n2 whole square and whole under root. So now just place the values which is already given. Sum of x square is given, sum of y square is given. So 43504 plus 42223 over 15 plus 15 minus 52.5 whole square and this gives us 10.065 or approximately 10.1 up to 3 SF. Wait, let me check the calculation of mean again. 792 plus 783 over 792 plus 783 over 30. let me correct it. I have forgotten to divide it. So this is actually 52.5. Question number 7. In a game, player attempt to score a goal by kicking a ball into a net. The probability that Lino scores a goal is 0.4 on any attempt, independently of all other attempts. The random variable x denotes the number of attempts that it takes Lino to score a goal. Find probability x is equal to 5. Since the number of times means n, the experiment is done. Actually, the experiment is not known. Number of times, how many the experiment gonna be repeated. So then it is GP, geometric progression. Geometric distribution. So for geometric distribution, we use a formula probability x equals r equals p times q power r minus 1. P is your success and it is given 0.4. Q is your failure, which comes from 1 minus subtracting 0.4 from 1. So we get 0.6. So now probability of x equals 5. Your success is 0.4. Write in P. Your Q is 0.6 power. R minus 1 means 5 minus 1, which is 4. Now you use your calculator. So you get 0.0518 answer. Find x is less than 7 greater than equal to 3. So less than 7 greater than equal to 3. So this gives you probability of x is equal to 3 plus probability x is equal to 4 plus probability x is equal to 5 plus probability x is equal to 6 plus probability x is equal to 7. So simply you just insert the values. Probability x is equal to 3 means 0.4 times 0.6 power 2 plus probability x is equal to 4 means 0.4 times 0.6 power 3. Probability x is equal to 5 means you just worked with it in the previous part, 0.4 times 0.6 power 4. Probability of x is equal to 6 means 0.4 times 0.6 power 5. Probability x is equal to 7 means 0.4 times 0.6 power 6. So this part is 18 over 125. This is 54 over 625. This is 162 over 3125. And this is 486 over 15625. And the last one is 1458 over 78125. So the whole thing gives you 0.3320. So 0.332, which is 3 SF, 3 significant figures. C part. Find the probability that Lino scores his second goal on or before his fifth attempt. So second attempt, so goal, this is 0.4, it's success, so 0.4 square. Third attempt, goal, success, then failure, then success. So 0.4 square times 0.6 times 2 factorial, because of 2 g's here, so they can interchange. Fourth attempt, so success, failure and success in 4 attempts. So 0.4 square, 0.62 times. So this is 3 factorials divided by 2 factorial because of 2 g's. The fifth attempt, 2 goals before 5 attempts. So first attempt, goal, fail, and then goal. So this is 0.4 whole square times 0.6 power 3 to, because of 4 attempts, so 4 factorial divided by 3 failures, so 3 factorial. Now if you solve all of them, you will get the result 0.6. You have to add their results, 0.663. Lino has 75 attempts to score a goal. Use a suitable approximation to find the probability that Lino score more than 28 goals but fewer than 35 goals. So X is normally distributed. NP, this is N is 75 and P is 0.4. So number of trials are fixed, so it is binomial. So let's see if NP is greater than 5. This is our N, this is our P. So let's see NP is greater than 5. So you multiply 75N and you multiply 0.4. You get 30. That is definitely greater than 5. Now see NPQ greater than 5. So your N is 75, P is 0.4 and Q is 0.6. So this comes out 18 and this is also greater than 5. So now change it to normal. Oh sorry, this is actually binomial. This is your binomial and we have to change it to normal now. So change from X to Y. So Y is normally distributed. mu comma sigma square. So NP is your mu and NPQ is your variance, which is denoted by sigma square. So y is normally distributed 30, 18. So probability y is less than 35 and greater than 28. Since we are moving from discrete variable to continuous variable, so we need continuity correction. So y is less than 35 and greater than 28. So I can say that y is less than 34.5 and greater than 28. So I can say that I can write 28.5. So this is my continuity correction. So I can write it in the way probability y is less than 34.5 minus probability. Actually the difference, I'm taking the difference. Probability y is less than 28.5. So standardize them. Probability z is less than 34.5 minus 30 divided by root of 18 minus probability z is less than 28.5 minus 30 over root 18 . So from here, first part, probability z is less than 1.061 minus probability z is less than minus 0.3536. So probability z is less than 1.061 minus, because this is negative, so I have to subtract from, I have to flip it on the right side, so I have to subtract it from 1. So I will write 1 minus probability of z is less than positive 0.356. Probability z is less than 1.061 plus minus into minus plus probability z is less than 0.354 minus 1. So from the table I get result of 1.061 as 0.8556 plus, and from the table I get the result of 0.354 as 0.6383, and this minus 1, and the whole answer would be 0.494. Thank you.